All right, so if we look at the first one, A, we've got a sine plus a sine. So you have to remember that it is, we're going to be using this one. So sine cos A minus B on 2 is sine A plus sine B. So we've changed the product to sums formula that we're given to the sums to products. We're going this way now. All right, so using that, A is 35, B is 25. So I'll just write left-hand side, which equals blah, 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 sine 35 plus sine 25 equals 2 sine 35 plus 25 on 2. I would actually, I should write that. 35 plus 25 on 2, and cos 35 minus 25 on 2. So it becomes sine 30 and cos 5. And we know sine 30 is a half. So we've got a half times 2 is 1. So we get cos 5. Now that's not the answer, but don't worry, because we know that cos and sine are complementary. So that's the same as sine 90 minus 5, which is equal to sine 85. So we can get our right-hand side. Okay, so same here with B. We're cos minus cos. So for the cos minus cos, I've got 2 sine A plus B on 2. I'm going to get rid of that. There we go. And sine A minus B on 2. That is the cos A minus the cos B. Remember that? All right, so using that, our left-hand side, if I write my left-hand side equals cos 36 minus cos 84. So now what have we got? We've got 2 sine. I'm going to add 36 and 84 on 2. And then we've got sine again. And this time I've got 36 minus 84 on 2. So what have we got here? We've got 2 sine 60, 120 on 2, so sine 60. And sine, this will be minus 24. Now, remember sine is an odd function, so I'm going to put that minus in front. So it would be minus sine 24. And also sine 60 we know is root 3 on 2. So this is sine 24 now. So the 2's cancel, we get minus root 3 sine 24, which is what we were looking for. That's our right-hand side, so we're all good there. All right, for C. So don't forget, slow down the video if you need to. All right, for C, what are we using here? For C, we've got a sine plus a sine. So I want both this one, whoops, sine plus a sine. So I've got, this one is our sine plus sine. And we want cos plus cos for the denominator. So we want this one. A minus B on 2, that's our cos plus cos. One there. All right, so I won't write it down because it's too much. So that left-hand side is all of that. So what have we got here? We've got 2 sine. So we're going to have 3 theta plus theta, so 4 theta divided by 2. And then 3 theta minus theta, so 2 theta divided by 2. All over, all right, so 2 cos 3 theta plus theta is 4 theta divided by 2, and 3 theta minus theta is 2 theta divided by 2. And you'll see these cancel, we've got sine 2 theta and cos 2 theta, which is tan 2 theta, which equals the right-hand side, therefore that equals that. All right, so let's look at D being probably the most challenging. So the trick with D is to change put the sine 6 alpha with the sine 2 alpha, so the edges, and keep the sine 4 alpha separate. Same with the bottom, cos 6 alpha, put it with the extreme ones, so cos 2 alpha, and keep the minus cos 4 alpha separate, right? We're looking for a tan 4 alpha, so that's another kind of hint. We're going to keep the 4 alpha separate. So again, using those same 2 that we had before that I've rubbed out, if but hopefully you remember them. So if I have a sine plus a sine, that comes from a 2 sine blah cos blah, 2 sine A cos B. 2 sine add divided by 2, so 6 alpha plus 2 alpha is 8 alpha, divided by 2 is 4 alpha, and then subtract 6 alpha minus 2 alpha is 4 alpha, divided by 2 is 2 alpha. Alrighty, and we've still got that minus sine 4. Cos plus cos, so cos plus cos comes from 2 cos cos, 2 cos cos. So cos we're going to add together, so 6 and 2, 8 divided by 2, 4, so 4 alpha. 6 minus 2, 4 divided by 2 is 2 alpha, and we're going to keep that cos 4 alpha there. So you can see that the top we can factorize by sine 4 alpha. We get cos 2 alphas minus 1. And the bottom we can factorize by cos 4 alpha, and we get 2 cos 2 alpha minus 1. So we can see they cancel, and what are we left with but tan 4 alpha, which is what we wanted.